Alright, welcome to the second part of the friction video where we go over some calculation examples. Part of the calculation, we have to know what the coefficient of friction is. In some situations, the problem will tell us directly. In others, particularly for the textbook and the workbook, they might not. But that's because in the textbook and in the workbook, there's a chart. In the textbook, it's on page 129, and in the workbook, it's on page 87. That has a bunch of these coefficients in there, both for kinetic friction and for static friction, for certain combinations of surfaces. So if you don't see it and you think you need it, that's your number one go-to place. And one trend, just like we said that the kinetic friction is always less than the static friction, and we see that in the coefficient. So the coefficient of kinetic friction is always lower than the static friction. So let's look at this example. We're pushing a 25 kilogram wooden crate across a wooden floor at a constant speed of 1.0 meters per second. How much force do you exert on the crate? Doesn't tell us the coefficient, but it says it's a wood crate on a wood floor. So if we go into the textbook, we can find wood on wood. Kinetic friction coefficient is 0.20. So we've got our list of givens, the mass. Instead of writing the velocity, because that's not something we worry about in forces, I wrote the acceleration, because that does matter. We're told a constant speed, acceleration is 0. And what we're looking for is our applied force. So we need to draw a free body diagram. So direction, if you drew it left or right, doesn't matter, but I'm just going to say my applied force is this way. And then I'm going to have Fk is going in the opposite direction that we're moving, which is going to be opposite our applied force in this case. And then I'm going to have Fg and Fn. So we want to find Fa. Now the big thing that we haven't talked about before is horizontal versus vertical. Just like for projectiles, we can solve them separately. So what we're going to do is we're going to look at the horizontal direction only. Our Fnet in that direction. So we're going to do horizontal only. So Fnet is 0. Fnet would be Fa plus Fk is equal to 0 newtons. We want to apply our directions, Fa minus Fk. And so that tells us that Fa is equal to Fk. Great. If we knew the force of friction, we'd know the applied force because it has to be equal. Well, let's figure out the friction. That is going to be mu k Fn from our equation before. We don't know what Fn is right now. And it's not something that we can figure out, but we can if we look at the vertical direction. So now we're going to look at the vertical only. And we're going to do the same thing and see if we can figure out Fn, our normal force. And so we get very similar things to start with Fn and Fg this time, because that's our vertical direction. And we're going to get Fn minus Fg is equal to 0 newtons. So Fn is equal to Fg in this situation. And we know Fg is mg, which is going to be 25.0 kilograms times 9.80 meters per second squared, and that's going to equal 245 newtons for our normal force and for Fg if we were worried about Fg. So now we have Fn. So we can just plug in mu k, which is 0.20, and we're going to have to multiply that by 245 newtons, and that's going to give us 49 newtons. And that is our final answer. So in forces, just like we did for projectiles, we can look at the horizontal forces only and the vertical forces only. And this will help us be able to solve friction problems so that we're not trying to combine all of the forces into one equation. You can skip some steps. So if you know that the vertical direction is going to give you Fn is equal to Fg, you can skip some of those in-between steps the more that you do it, but don't skip all of them. You got to show some of your work and some of your thought process. So let's take a look at the second example, which is related. So we've got the same force, the same crate, but now the force that we're applying to it is doubled. So our applied force is doubled. What is the resulting acceleration of the box? So if we're applying more force, we're going to accelerate. So we've got the same mass, the same coefficient. Our applied force is double, so 2 times what we had, which was 49 newtons. And our friction force has to be the same because that depends on mu k, which is the same, and Fn. Fn hasn't changed, so our force of friction also has to be the same, which we know to be equal to 49 because of this line right here. So we can now we just want to solve. We don't have to draw a free body diagram because we've done it already. So what we want to look at is the horizontal direction. So we're going to do we're going to do horizontal F net. So we have F net is equal to MA. In the horizontal direction, we're still going to have FA plus FFK. And take away our vectors, apply our directions, is equal to MA. And what we're going to see is an equation for A is equal to FA minus the force of friction, kinetic, all divided by the mass. So we can plug our numbers in. A is going to, so FA, so that's going to be 2 times 49, which is going to be 98 newtons, minus 49 newtons, all divided by the mass, which is 25.0 kilograms, and our acceleration is going to work out in our calculator to be 1.96 meters per second squared, but by sig figs, it will have to round to 2.0 meters per second squared. So that's our acceleration. So that's just an idea of how we can relate examples to what we've done before, and everything still comes from F net. All we have now is a tool to calculate the force of friction, knowing that that is mu times the normal force. So it just gives us another tool to solve more problems, but the process is the same every time. Start from F net, draw a free body diagram, apply the directions, and solve it so that you know what you want to look for. If you follow the same pattern, you're going to have success with these problems. So there's a number of friction problems that you can try here. 4 out of the textbook, 3 out of the workbook. 3 of those problems will make its way onto the formative questions. And we'll see you in class. Physics is awesome.